Hello all, and thank you for listening to Mr. Laxton's video on these Section 3.4 Algebra 2 notes. And today we're looking at linear programming. And before we get into some linear programming here, make sure you hit that subscribe button to Mr. Laxton's channel. I need all the subscribers I can get. Alright, perfect. Let's get in here. Linear programming, I'm going to be honest with you, is kind of a culmination of a lot of things that we've been talking about so far. It's going to be a combination of this of the systems of linear inequalities. We're going to take that shaded region and we're going to do some more things with that today. All right, and this linear programming in this specific note section here is kind of just a broad, I give you all the different numbers and things like that, but there's really a lot of real world examples about these. All right, we're going to look at some word problems that look into like a bakery, and if they have X amount of hours to do baking and X amount of hours to do like the prepping of the actual foods, how many hours should they spend on each one of those to make so many pastries or whatever they're making on to maximize their profit. All right, so it's all about maximizing a profit and about making the most money, right? That's what we want to do. And I used to work for a grocery store, and this linear program was embedded into a computer system that we had, but it was kind of the basics behind it. Is that we had so many hours to spend, and we had so much man hours that we needed to put forth. How much are we going to do of both of those things to maximize our profit as a grocery store? So that's what we looked at every week to maximize our profit, to how much we had to pay each employee and things like that. All right, so obviously that was a lot more intense than what we're going to look at, but it's got that kind of written behind it. All right, so optimization here, this first kind of, if I jump into the vocab words here, it's just finding the maximum or minimum values of some quantity. So it's the optimization, as we find the maximum or minimum. All right, so the linear programming is the process of optimizing a linear objective function subject to a system of linear inequalities called constraints. All right, so these constraints, as I look down here, are going to be my linear inequalities in two variables that make up a feasible region. So as I look down here, this is my feasible region. This is that shaded region, that overlapping shaded region that we worked on in the last section. My objective function is the numbers that you plug the final numbers into. All right, so this gives you your max and your min. So this is actually that equation of hey, if I put in 4 hours of baking time and 1 hour of prep, that's going to maximize my profit to be this. All right, you're going to make $120 or whatever it might be. All right, that'll give you your actual maximum or minimum. All right, the feasible region is exactly what we just talked about here. Down this here is the feasible region, is this shaded in area. So it's the graph of the system of constraints. All right, we kind of looked at that before. All right, so this example number one, that's not what I meant to do. Example number one, it gives us the feasible region. It gives us all my intercepts. It gives us all these things, and really we just need to plug it into this objective function to find the max and the min. All right, so as I look here, it gives us these points. It gives us 0, 0. So I'm going to try that in here. I'm going to plug in 0, 0. It gives us that one of my points is 0, 6. So I have 0, 6. It gives me that one of my points is 4, 4. So I'm going to plug in 4, 4. And it gives me that one of my points is 6, 0. So these are the points on which this feasible region is kind of, those are the vertices of that feasible region. So those are the corners of that feasible region. All right, so as we go through here, it's just as easy as this. For the first one, I'm just going to plug these guys in. I have an x and a y to plug into my objective function here. So I have 2 times 0 plus 4 times 0. All right, now here I have 2 times 0 plus 4 times, 4 times 6. Now here I have 2 times 4 plus 4 times 4. And then down here, I have 2 times 6 plus 4 times 0. All right, so now I just, easy as this, find out, hey, which one gives me my maximum and which one gives me my minimum. So I look here, 2 times 0 plus 4 times 0, that is going to be 0. A lot of times it's 0, 0 is going to be your min. Not always, though. You always got to check it. So now here, 2 times 0 is 0, plus 4 times 6 is 24. All right, and here, 2 times 4 is 8. 4 times 4 is 16. 8 and 16 is 24. All right, and the bottom one here, 2 times 6 is 12. 4 times 0 is 0, so this guy gives me 12 out of there. All right, so notice here that it's just as easy as this. This is my max, and look at this. I can have 2 maxes, and that's okay. All right, there's 2 points that both give me the same max. That's okay. And then now, obviously, that 0 is my min. All right, so that's all we're really looking for there is just, hey, which one maximizes and which one minimizes your objective function. Awesome. So here we go. Example number 2 is where we actually have to do the whole shebang here. I don't even know. I just made that word up. We got to do the whole shebang. We got steps for graphing these and solving linear program. We have to graph this feasible region by graphing the constraints and the inequalities. Okay, so we're going to graph and we're going to actually make this shaded region, and then we're going to identify the ordered pairs to plug into this feasible from the feasible region to plug into my objective function. Okay, and this first one and this example is going to happen a lot here is that these two guys are actually pretty nice. X is greater than or equal to 0 is a vertical line at 0 right there. So it's everything greater than that, and it's everything greater than y is greater than 0. So it's going to be everything in the first quadrant right here. So this is the first quadrant. All right, I'm not going to do the shading just to save me some hassle from trying to find out what looks like what. Now, we also have to graph this guy here, so I'm going to subtract the 2x, subtract the 2x. So now I get y is less than or equal to negative 2x plus 8. All right, and now I have to graph this guy, so I go up at 8. So here is 8 way up here, and then I go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Okay, again, that is a solid line, and you kind of notice here, and this is going to happen that every time, is that this shaded region is everything less than that. So my shaded region is everything that is right in here. All right, it's usually either a triangle or it might be a quadrilateral of some type right in there. All right, so I'm going to kind of make this look good for us here so we see that this is my region. Awesome. So that is my feasible region, just like we kind of had up here that they made for us. All right. So now here I got to pick out these points, it says. So here, don't forget 0, 0, 0, 0 is usually always 1. 0, 0. Up here is this point right here, which is 0, 8. And this point over here is going to be 1, 2, 3, 4, 0. Right there. All right. So now I just have to take these points. I go 0, 0. I go 0, 8. And I have 4, 0. And I plug them into the objective function, which they give us here. So now I'm going to find out which one gives me my maximum, which one gives me my minimum. So now as I plug these guys in, I get 0 plus 5 times 0. Here I have 0 plus 5 times 8. Here I have 4 plus 5 times 0. Plug these guys in. 0 and 0 is 0. This one's going to be 40. 0 plus 5 times 8 is 40. And this one's going to be 4 plus 0 is 4. All right. Awesome. So here my minimum is 0 and my maximum is 40. All right. So that is my min and my max. So that's kind of the deal there. Graph those equations. Find that shaded region, and then find the points that make up that shaded region are those vertices. Okay, plug them into that objective function and go from there. All right, so we're going to look at, in the next couple days, we're going to look at some examples of real life linear programming and say, hey, what actually maximizes my profit here? Okay, so these are just the basic ones, finding my minimum and maximum. Hopefully they're not too bad, and we're going to toss in some word problems and real life stuff in the next couple days. All right, thank you for listening. Have a good rest of your morning, your afternoon, or your evening. Have a good rest. See you later.